10 to Dear students, in the previous lecture we started a topic called sensitivity analysis. In that we have discussed the effect of change in objective function coefficient on our optimal value. In this class we will discuss the effect of change in right hand side value of the constraint on our problem. The agenda for this lecture is what is the effect if any value changes on the right hand side of the constraint. Then we will discuss about what is the dual value, the another name is shadow price. Then there is another term called reduced cost. Okay. Now first we will see the changes in the right hand side of the constraint. This problem I have taken, which we are discussing right from the beginning of this course. Consider how a change in the right hand side of a constraint may affect the feasible region and perhaps cause a change in the optimal solution to the problem. So, what we are going to discuss, if any changes here in the right hand side of the constraint, how that will affect our feasible region, thereby how that will affect our optimal solution. To illustrate this aspect of sensitivity analysis, let us consider what happens if an additional 10 hours of production time become available in cutting and dyeing department. Okay. So, the right hand side of the cutting and dyeing constraint is changed from 630 to 640 because we got 10 hours additional resources. Now, our constraint will become like this 7 upon 10 years plus D less than or equal to 640. Previously it was 630. We have added another 10 unit of resources, now it become 640. By adding that 10 unit of these resources, now you see that there is a region that our feasibility region is extended. Now this was the after adding 10 unit of additional resources. The initial one was in the dotted line. Because of this 10 unit increase on the right hand side, now the feasible region is increasing, that is shown in the shaded region. That shaded region shows that increase in the feasible region due to additional 10 units on the right hand side of the constraint. By obtaining an additional 10 hours of cutting and dyeing time, we expand the feasible region for the problem as shown in figure. Here also there is a this much unit is additional area due to additional resources of 10 units. With an enlarged feasible region, we now want to determine whether one of the new feasible solutions provides an improvement in the value of the objective function. So, application of graphical solution procedures to the problem with an enlarged feasible region shows that the extreme point with S equal to 527.5 and D equal to 270.5 now provide the optimal solution. Now what has become? Our previous solution is changed due to addition of this 10 units. Now the new solution is this one 527.50, then another one is D equal to 270.75. The new value for the objective function is when you substitute this. So 10S plus 9D, now the value of S is 527.5, value of D is 270.75. Now this is 7711.75 is the new value for our objective function. So how much is increase has happened due to that 10 additional resources. So when our earlier solution was additional value of objective function is 7668. By adding 10 unit resources, now our objective function value is increased this much. So the total increment for 10 additional unit of the resources is 43.75. So if you want to know per unit, when you divide by 10, so this is $4.375 per hour added. So what has happened now? By adding 1 unit additional resources on the right hand side of the constraint, Okay. Increased value in our objective function is 4.375. This 4.375 is nothing but our dual value. Dual value. The change in the value of optimal solution per unit increase in the right hand side of the constraint is called dual value. Here the dual value for the cutting and dyeing constraint is 4.375. In other words, if we increase the right hand side of the cutting and dyeing constraint by 1 hour, the value of the objective function will increase by $4.375. Conversely, if the right hand side of the cutting and dyeing constraint were decreased by 1 hour, the objective function will go down by 4.375. So, the dual value can generally be used to determine what will happen to the value of the objective function when we make 1 unit change in the right hand side of a constraint. Dear students, now I will explain with the help of Excel what is the effect of the 10 unit change on the right hand side of the first constraint on our objective function. So, as usual, what I have explained in my previous class, I have entered the value in Excel. So, this is initially take it to 0, this is my decision values. Okay. Now, right hand side is 630. I have used this is the resources constraint as usual, because for the this is the problem for which I have made the Excel solver. So, when I go to data solver, yes, when I solve it, the objective function value is 7668. Now, what I am going to do? I am going to increase in F6 instead of 630, I am going to increase this to 640. So, when I make 640, again I am going to run it, solver. Now, this is 7711.75. So, the difference is 43.75. This is for 10 unit. If I want to know for per unit, so equal to this value divided by 10 is, that is 4.375. What is the meaning of this 4.375? If the right hand side is increased by 1 unit, the increased value in the objective function is 4.375. This is nothing but our dual value. The value of the dual value may be applicable only for small changes in the right hand side. For example, 1 unit increase or 10 unit increase. As more and more resources are obtained and the right hand side value continues to increase, the other constraint will become binding and limit the change in the value of objective function. For example, the problem which we are discussing, we would eventually reach a point where more cutting and dyeing time would be no value. It would occur at the point where the cutting and dyeing constraint become non-binding. At this point, the dual value would equal to 0. Note that the dual value for any non-binding constraint will be 0 because an increase in the right hand side of such constraint will affect only the value of the slack or surplus variable for the constraint. Because for the non-binding constraint already there will be a slack or surplus variable. We know that the effect of the slack and surplus variable on the objective function is 0. So, for non-binding constraint, adding any resources on the right hand side will not make any difference in our objective function value. So, how we can generalize for the dual value? There are two possibilities. The objective function may be maximization or minimization. If the constraints are less than or equal to type unbinding, so in this situation the optimal objective function value get better. What is the meaning of to get better? If the objective function is maximization type, if the constraint is less than or equal to type, so adding one resources on the right hand side will increase your value of maximization function. Other way, if the objective function is minimization type, if the constraint is less than or equal to type, by adding one resources will minimize your objective function. That is the meaning of get better. So, because what is the meaning of adding any resources for the constraint which are less than or equal to type? That means that you are providing extra resources. So, when we for less than or equal to type, when you are adding extra resources, obviously the efficiency of that system will increase. What is the meaning efficiency? If it is a maximization, the problem will bring more, the value of objective function will increase. If it is a minimization, the value of objective function will decrease. On the other case, if the objective function is maximization or minimization, but the constraint greater than or equal to type unbinding. Now exactly here what is happening here, if you are tightening the constraint. So when you are tightening the constraint, the objective function value to get worser. What is the meaning of worser? If it is maximization type, if the objective function is greater than or equal to type, if you are adding one resource on the right hand side, your objective for the maximization type, the value will decrease. For the minimization type, the value will increase because you are tightening. Tightening means you are not providing more freedom because the expectation is increases. For example, yes, say minimum should be 500. Okay. Suppose if you say this is an greater than or equal to 7, assume that this is a binding constraint. Suppose if you are making this should be 501. So what is happening that your expectation is increases. When the expectation increases, the efficiency of that system will decrease. That means if it is a maximization, your profit will decrease. If it is a minimization, your cost will increase. That is the generalization of this dual value, either for constraint which are less than or equal to type or constraint greater than or equal to type. Cautionary note on the interpretation of dual values. Now there are two terms which you need to understand, a sunk cost and relevant cost. What is the sunk cost? A sunk cost is one that is not affected by the decision made. It will be incurred no matter what values the decision variable assumes. For example, if say constraint number 1, the amount which was sent, amount which are spent for acquiring that constraint number 1, it is a sunk cost. Even though adding extra resources, that will not be reflected on our objective function. So there is no point in adding extra resources when the cost is sunk cost. Then what is the relevant cost? The relevant cost is one that depends on decision made. The amount of a relevant cost will vary depending on the value of the decision variables. Only relevant cost should be included in the objective function. So when we interpret the meaning of dual values, the meaning of dual value is applicable only for the relevant cost, not for the sunk cost. What is the relevant cost? By adding extra resources that will help to increase your objective function. Now I will explain with the help of the problem which I have taken. The amount of cutting and dyeing time available is 630 hours for this problem. See, 630 hours. Cost of the time available is a sunk cost if it must be paid regardless of number of standard and deluxe golf bag produced. When it will become sunk cost, see the salary is fixed for the employees. Okay. Whether you produce 631 or 640, the salary is fixed. So that time the salary become the sunk cost. So it would be relevant if it would be relevant cost if par incorporation for that problem which you have discussed only had to pay for number of hours of cutting and dyeing time actually used to produce the golf bags. Many time in the industry context, if there is a contract employees, you pay the money based on how much bag has produced. So, that money which you are spending for them, that is becoming a relevant cost. Assume that it is a permanent employee, whether he produce 630 or 640, the salary is fixed, that cost is sunk cost. So, the point which I am trying to say here is the interpretation of dual value is applicable only for the relevant cost. So, the point here, all relevant costs should be reflected on the objective function of a linear programming problem. Sunk cost should not be reflected in the objective function. For the problem which we are discussing, we have been assuming that the company must pay its employees wages regardless of whether their time on the job is completely utilized. Therefore, the cost of the labor hours resources is a sunk cost and has not been reflected on the objective function. So, this is the caution which you have to note down at the time of interpreting the dual value. What is that point which you have to remember? The interpretation of dual value is only applicable for relevant cost, not for the sunk cost. Now, we will go back to our initial problem. Now, we will discuss the Excel output, solver output to interpret the sensitivity analysis. What are the terms we are going to interpret? What is the slack variable? What is the surplus variable? What is the range of optimality? What is the shadow price, dual value, and what is its interpretation? I have brought the output of our solver. Now, I am going to explain how to get the sensitivity analysis report in the solver. So, I have entered the problem. We know that as usual this is the resources utilized, this is the right hand the sign of the constraint, this is right hand side values. So, go to data, go to solver. So, when I am solving, so I got this one, you see that there is an answer sensitivity limits, then press OK. So, now you got there is answer report is there where you can get the value of objective function 7668. Then we got the value of B2 cells, that is the S, value of S is 540. You can make it center. Okay. So, the value of S is 540, value of D is 252. Similarly, this also you can make it center. Now, there is a slack. I will explain what is the meaning of this slack. And when you go to sensitivity report, here also there is value of S is there, D is there. There is a term called reduced cost. Then there is a allowable increase and allowable decrease. So, I have taken the screenshot of this output. I will explain in the presentation. Similarly, in the constraint, I will center it. Okay. Here there is a final value of constraint. There is an important term called shadow price. Shadow price is nothing but dual value. Some books they call it shadow price, some books they call it dual value. So, this is, can you see that this is a 4.37, that is if this constraint cutting and dyeing, if the right hand side is increased from 630 to 631, the objective function will increase by 4.37 units. Okay. And here also there is a currently the right hand side is 630, there is allowable increase and allowable decrease. Similarly, for other constraint, for sieving constraint, for finishing constraint and the last constraint. After that there is another report called limit report. In the limit report, here also there is a lower limit, upper limit and corresponding objective function value. For example, the value of S lower limit is 0. So, in our objective function, if you substitute S equal to 0, the objective function value is 2268. Suppose in that objective function S equal to 0, instead of 0 when you put 539, you will get 7667. The second one what says that the value of D, if we put 0, the value of objective function is 5399. If we put 252, we will get 7668. I have taken the screenshot of this output, then I will explain hereafter. With the help of screenshot, I will interpret this answer. Now, from this we can see the value of S is 540, value of D is 252. Now, you see that there is an allowable increase. So, from 10 it can be increased to 3.4, that is 13.4, allowable decrease 3.7. Similarly, for our second decision variable, the value of D is 9, it can be increased 5.2 and it can be decreased by 2.33. So, this portion says range of optimality, range of optimality. What is the meaning of range of optimality? Even though the value of objective function is increased by this 3.4 and decreased by 3.7 for the first decision variable, our this value, that is 540 and 252, will remain same. That is called range of optimality. Second, you see that there is a shadow price. What is a shadow price? For this constraint, cutting and dyeing, if the right hand side is increased by 1 unit, your objective function value will increase by 4.37. You see that this is a binding constraint, which one, cutting and dyeing. But see the second constraint, sieving constraint, okay. Already there is a slack variable is there. We will come back, where is the slack variable here. For the sieving constraint, already there is a slack. I will interpret, I will come back to the later this one. So, for the value of shadow price is applicable only for binding constraint. For non-binding constraint, the value of slack variable, value of dual value is 0. Okay. Here also the right hand side constraint can be increased 52.36 and decreased 134 without affecting the shadow price. This is called range of feasibility. The first one is called range of optimality, this is called range of feasibility. At the bottom there is a slack variable. For example, the first constraint, cutting and dyeing, the slack variable is 0. What is the meaning? Slack is here, if it is all are, since all the constraints are less than or equal to type, this is unutilized resources. That means we have fully utilized cutting and dyeing department resources. Similarly, for finishing department also we have fully utilized, that is why the slack is 0. For other constraint, for example, sieving and inspection, we have a positive slack. That means that 120 units in sieving department is 120 unit of resources, I think hours is not utilized, and here 18 hours is not utilized in the inspection and packaging department. Now we will go to in detail interpreting this output. So, from this information which are given on the right hand side, we see that binding constraint, what are they? Cutting and dyeing and finishing constraint have 0 slack at the optimal solution. Where are they? Here, there is this and this. The sieving department has 120 hours of slack, this one, or unused capacity, and the inspection packaging department has 18 hours of slack or unused capacity. This is 17.99, 18. So, the dual value column contains information about the marginal value of each of the 4 resources at the optimal solution. So, the dual value here is the shadow price, this portion. If the resources is increased by 1 unit, corresponding increase on the objective function, that is called the marginal value of each of the resources at the optimal solution. Then interpretation of this dual value. The non-zero dual values of 4.37 for a constraint 1, that is for cutting and dyeing constraint, and 6.93 Where is 6.93? This one 6.93 for finishing constraint tells us that an additional hour of cutting and dyeing time increases the value of optimal solution by 4.37 and additional hours of finishing time increases the value of optimal solution by $6.94. That is, if the cutting and dyeing time were increased from 630 to 631 hours with all other coefficient in the problem remaining same, that is an assumption. We are making one change at a time, okay. Then the profit would be increased by 4.37, that is 7668 to 7668 plus 4.37, that is from 7,668 to $7,672.37. A similar interpretation for the finishing constraint implies that an increase in from 708 to 709. So, this one 708, if you add one additional unit in that department, what is the condition with all other coefficient in the problem remaining the same? So, the increase in profit is 7,674.94. This is an interpretation of dual value. Because the sieving and inspection and packaging constraint both have slack or unused capacity available, the dual value of 0 shows that additional hours of these resources will not improve the value of objective function. Because these two department, which one, that is this department, already they have unutilized resources. By adding extra resources again in that two department, there is no use. So, that is the meaning of this one. For a non-binding constraint where there is a positive slack is there, adding any extra resources for that constraint will not improve our objective function value. The another term we are going to say that is called reduced cost. This also a kind of a dual value. So, the reduced cost associated with the variable is equal to the dual value for non-negativity constraint. This also kind of a dual value, but this is for non-negativity constraint associated with the variable. Where is the reduced cost is there? Here. So, there are two, these are non-negativity constraint because we are assuming that the decision values are greater than or equal to 0. What is a non-negativity constraint? S is greater than or equal to 0, D is greater than or equal to 0. So, the dual value corresponding to these two non-negativity constraint is nothing but your reduced cost. Why it is named reduced cost? I will explain. From the figure, we see that the reduced cost on variable S is 0, on variable D is 0. This makes sense. Consider variable S. The non-negativity constraint is greater than or equal to 0. But the current value of S is already 540. So, changing the non-negative constraint 0 to 1 has no effect on optimal solution. Already we got the value of S is 540, but by adding one unit on the right hand side of non-negative constraint will not make any result. Okay. That is why the reduced cost is 0, because increasing the right hand side by one unit has no effect on optimal objective function value. That is the dual value of this non-negativity constraint is 0. The another name for dual value for the non-negativity constraint is reduced cost. Then we will talk about ranges for coefficient of objective function. Where is there? This one. Currently for value of S it is 10 and value of D the coefficient of S is 10, coefficient of D is 9. So, we will discuss about ranges for coefficient of objective function. This is called range of optimality. Consider an objective function coefficient range analysis. Here you have to concentrate here. We see that the variable S which has the current profit coefficient of 10, this one, and has an allowable increase is 3.5 and allowable decrease is 3.7. Therefore, as long as the profit contribution associated with the standard bag is between, so allowable decrease is 3.7, so $6.30 and allowable increase is 3.5, $13.50. Okay. The production of S is 540 standard bags and D equal to 252 deluxe bags will remain optimal. So, what here says that the value of objective function can be increased to the level of allowable increase and can be decreased to the level of allowable decrease quantity. So, that will not affect our final solution. That is the meaning of range of optimality. Then we will go for range of constraint. This is called range of feasibility. So, here where is the range of constraint? You see this one. For example, the first constraint, the final value is the right hand value is 630, allowable increase is 52, allowable decrease is 134.4. As long as the constraint right hand side is not increased or decreased by more than the allowable increase, the associated dual value gives the exact change in the value of optimal solution per unit increase in the right hand side. What is the meaning of this one? If you increase the right hand side value by 630 plus 52 and decrease 630 minus 134, your dual value will remain same. What is that? The shadow price will remain same. That is the meaning of this range of constraint. Actually, what is happening here? When you add additional resources means the area, the feasibility region is increases if the constraint is less than or equal to type. So, when the feasibility region is increases, up to certain point your shadow price will remain constant. After beyond certain points, this shadow price will get affected. So, when as long as this increase is within this range, that is 630 plus 52 and 630 minus 134, the shadow price will remain constant. That is the meaning of this range of constraint. That is called range of feasibility. For example, let us consider cutting and dyeing constraint with current right hand side value 630. Because the dual value for this constraint is $4.37, we can conclude that the additional hours will increase the objective function by $4.37 per hour. That is what we studied about the dual value. It is also true that the reduction in hours available will reduce the value of objective function by $4.37 per hour. From the range information which is given here, we see that the dual value of $4.37 has an allowable increase of 52.36. This 4.37 is valid for right hand side value up to 630 plus 52 up to 682.36. Even though from 630 if you add more resources up to 682.3, your dual value will remain same. But if you go for say 683, your dual value will change. That is the interpretation of this. Like this, for each constraint we can see allowable increase. For example, the first constraint, the upper limit is 682.36, lower limit is 495.6. Within this range your dual value will remain same. When you go beyond 682 and less than 495, your dual value will change. That is the meaning of this range of constraint. So, what I have brought it for each constraint, I brought it minimum value, maximum value. For example, sewing department, there is a minimum value, there is no maximum, no upper limit. That is what we are learning it from here, because allowable increase is this one. Okay. Similarly, for finishing, the minimum value is 580, maximum value is 900. How we got this one? So, 708 plus 192, that will be 900, 708 minus 128, that will be 580. For inspection package currently this is 135. So, allowable increase is 10 to the power 30. So, there is no upper limit, but there is a lower limit 17.0. So, this much amount it can be, the right hand side can be increased or decreased without affecting the dual value. That is nothing but your range of feasibility. So, as long as the value of right hand sides are within these ranges, the dual value shown on the computer output will not change. The right hand side values outside these limit will result in change in the dual value information. Sometime the value of reduced cost will become negative. Let us see that kind of situations. For example, this was the the problem which we are keep on discussing for every lectures. Suppose this is a modified problem. What is that? The company is trying to introduce another type of bag, say that has lightweight. We know this is a standard bag, deluxe bag, lightweight bag. The profit contribution of that is 12.85. That also consume this much resources in cutting and dyeing department, sieving department, finishing department and inspection packaging. So, now this problem I am going to solve with the help of solver. I am going to show what is the value of reduced cost. This problem, the reduced cost will become negative. So, I will explain what is the meaning of that negative reduced cost. Okay students, now I have brought this modified our problem. What is that modified problem? We have introduced another product apart from standard bag and deluxe bag, there is a lightweight bag. This is 0. So, the coefficient we know already this is a 10s9d, this is 12.85, but these are the resources which are utilized by the lightweight bag as usual. So, here I am writing RU resources utilized. So, objective function is here, then this is resources utilized. So, now I am going to solve this one, data solver. So, when I solve like this, so I am going to see the other reports. Now, look at this sensitivity report. You see that the value of S is 280, the value of D is 0. It says that you need not produce deluxe bags, and for the value of L, that is a lightweight bag, is 428. Look at here, this is the reduced cost is negative minus 1.15. What is this interpretation of this minus 1.15? That means that if the cost of producing these deluxe bags, if it is reduced by $1.15, then you will get a positive value here, that is for we will get a positive value for the D. So, what is the meaning this? When you reduce this cost of manufacturing of deluxe bags, you will get a positive D value, that I will explain. So, what I am going to do? Now, I brought the output of our Excel solver. So, here we got the reduced cost for the D is minus 1.15. I will explain what is the meaning of this minus 1.15. The interpretation of this number is that if the production of deluxe bags is increased from current level of 0 to 1, then the optimal objective function value will decrease by 1.15. As I told you, what is the reduced cost? Reduced cost is dual value of your non-negativity constraint. The dual value is minus 1.15. So, what says that? So, we know that the constraint is like this, D is greater than or equal to 0. Suppose if you want to get some positive D value, that is if you are making D is greater than 1. So, this is the binding constraint, the decision values. So, what will happen? The optimal value will decrease by this much, because this is an objective function. So, the optimal value decrease by minus 1.15. Another interpretation is that if we reduce the cost of deluxe bags by 1.15, that is increase the contribution margin by 1.15, then there is an optimal solution where we produce a non-zero number of deluxe bags. So, what is the meaning? Suppose if we increase the coefficient of D by exactly $1.15, so that the new value will be $10.15 and we can resolve it. So, when we resolve it, now when you look at this Excel, this was our previous problem. So, there are 3 product, standard, deluxe and lightweight bag. There is a 10, 9, 12.85. When we are running this, we have seen the reduced cost is minus $1.15. Now, what we are going to do? So, we are going to add that much reduced cost value. So, 9 plus 1.15, this will be 10.15. Again I am going to solve it. So, before I am solving, you remember this, when the coefficient of deluxe bag is 9, our objective function was 8299, approximately 8300. So, now my coefficient of objective function is 10.15. Why it is a 10.5, previously 9? Because we have to reduce the cost. So, what is the meaning of reduced cost? Reducing cost means increasing the profit contribution. So, minus 1.15 when you reduce the cost. So, that means our profit contribution need to be increased. So, if I solve it again, you should be very careful this value of objective function also. So, when you solve it again, so I want to see the, now you see this, even though the coefficient is 10.15, again our objective function value is same, that is 8299.8. But when you look at the reduced cost value, you see that the value of reduced cost is minus 8.10 to the power minus 16 at almost 0. So, here we are not getting positive value. The reason is this problem is having multiple optimal solution. One limitation of using Excel for solving linear programming problem is, if the problem is having multiple optimal solutions, we can see any one value, we cannot see all possible multiple optimal values. How we are verifying this problem having multiple optimal solution? So, previously when the coefficient of D was 9, that time also our objective function was 8299. When I change this objective function to 10.15, coefficient of deluxe bag is 10.15, that also the value of objective function is remains same. So, like this, since this problem is having multiple optimal solutions, so there may be some possibility the value of D is some positive value, that we will discuss there. Now, I will explain what is the meaning of this reduced cost. Assume that, say, already this is 9D, okay. 9D is some quantity plus 2. Suppose the reduced cost is $1.15. So, that means from 9, if you are reducing $1.15, that is equivalent to adding $1.15 on the left hand side, that is increasing the profit contribution to 10.15. So, reducing $1.15, that is reducing cost, is equivalent to increasing the profit contribution. So, now the coefficient of D is 10.15. So, when I solve this problem, 10S plus 10.15 plus 12.85L, for this problem when I am solving, I got this output. So, what this output says, the value of S is 280, value of L is 428, but you see that the objective function value is same. When it was 9, that time also 8299, when it is 10.15, that time also it is 8299. That means this problem having multiple optimal solutions. But look at the value of reduced cost. So, the value of reduced cost is 0 here, because this is minus 8.8 10 to the power minus 16, it is 0. Now, you see that there may be another, because since I told you it is a multiple optimal solution, the value of S is 403.7, the value of D is 222.8881, the value of L is 155. So, when you substitute this value in the objective function, that time also you are getting objective function values same. So, what is the meaning this? This problem is having multiple optimal solutions. One of the solution is this 403, 222, 155. In that solution we have a positive D value. One limitation of this Excel solver is, if the problem is having multiple optimal solutions, we cannot see all possible optimal solutions with the help of Excel. But there may be some other software. The book which I am following they have used some other software. We got different value for S and D, L, L, that also providing the same value of objective function. Note that from figure that the dual value for constraint 3 and 4 is 8.1 and 19, 8.1 and 19 respectively, indicating these two constraints are binding in the optimal solution. Thus, each additional hours in the finishing department would increase the value of optimal solution by $8.10, and each additional hours in the inspection packaging department would increase the value of optimal solution by 19.0. Because the shadow price is 19, for this constraint, if the right hand side increases by 1 unit, our objective function will increase by $19. So, similarly for this also, because these two constraints are binding constraint, other two constraints are non-binding. So, adding any resources will not help you. The next term is degeneracy. What is degeneracy? Degeneracy occurs when the dual value equals 0 for one of the binding constraint. Generally, if the constraint is binding, adding any resources should increase your objective function value, but that means it should increase, there should be a positive dual value. But here you are adding any extra resources, for example, the constraint is less than or equal to type, you are adding any resources, but the dual value is 0, that situation is degeneracy. That means that adding any resources is not helping to achieve your, not helping to improve your objective function. So, that situation, but it is a binding constraint. So, that situation is degeneracy. Conclusion. Dear students, in this lecture we have discussed about the effect of change in the right hand side value of the constraint. Then we have discussed the meaning of dual values for binding and non-binding constraint. Then we have discussed about reduced cost and its interpretation. In the next lecture we will discuss about limitations of classical sensitivity analysis. Thank you.